I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss about basic theorems and properties of Boolean Algebra for the course Digital System Design. Boolean Algebra was invented by George Boole in 1854, and it is a mathematical system for manipulation of variables which have only two values. In formal logic, these values are either true or false, but in digital systems, these values are on and off, 1 and 0, or high and low. And this Boolean algebra consists of a set of laws and rules to define the operation of a digital circuit, and it helps to reduce the number of logic gates needed to perform a particular logic operation, and this results in a list of functions and theorems are known as laws of Boolean algebra. And now we are going to see the Boolean operator. So Boolean operator can be either and or. For example, we are given for AND operation. So in this AND operation, the truth table is given at the right side, and if both the inputs are 1 and 1, we get 1, otherwise we have 0. And for logical OR operation, if both are either any one of the input is 1, we get 1 as the output, and if both the inputs are 0, we get 0 at the output. And there are certain rules in Boolean algebra. We will see one by one. The first one is a variable used can have only two values. As we know, the binary logic have 1 for high and the binary 0 for low. And the another rule is the complement of the variable in Boolean algebra is represented by over bar above the variable. And for example, if we take a variable b and its complement is represented as b bar. So if b has the binary value 0 and b bar should be 1 and the complement of 0. Suppose if b value is equal to 1, its complement value b over bar is 0. So this is complement operation. Next, the ORing operation is given by plus sign in between the variables. For example, if we have three variables a, b and c, and the OR of these three variables will be represented by a plus b plus c. Okay, next is the AND operation. So that is multiplication operation. OR is the addition operation. So the logical ANDing of two or more variables is represented by writing a dot in between the variables. For example, again we are taking the three variables a, b, c. The AND of three variables will be given by a dot, b dot, c. And now we will see Boolean laws. So Boolean laws, there are 6 types of laws are available. So first law is commutative law. So any binary operation which satisfy the expression is a dot is b is equal to b dot a, or a plus b is equal to b plus a is referred as commutative operation. That means if the variables are interchanged, the result is same. That is a dot b is equal to b dot a, and a plus b is equal to b plus a. And next is the associative law. So this associative law states that the order in which the logical operations are performed is irrelevant as their effect is the same. For example, if we take a dot b dot c, and this is equal to a dot of b dot c. And similarly, we can also give another example. A plus b plus c is equal to a plus b plus c. So this is associative law. And the third law is distributive law. So distributive law states that a dot b plus c is equal to a dot b plus a dot c. And next is the AND law. AND operation law is and of 0, a dot 0 is equal to 0, a dot 1 is equal to a. And the same operator and operations result the same value. For example, a dot a is equal to a. And the complement gives the 0 value in AND operation, that is a dot a bar is equal to 0. And next is fifth law is OR law, addition law. So in OR law, a plus 0 is equal to a and a plus 1 is equal to 1. Whatever may be the value of a, either it may be 0 or 1, a plus 0 gives a and a plus 1 gives 1. And a plus a, so if we add the same variable 2 times, it results the same answer. A plus a is equal to a, and the addition of the variable with the complement is always equal to 1. A plus a bar is equal to 1. So this is OR law. So next we will see about inversion law. So inversion law uses NOT operation, and for example, if we take a variable a and its inversion is a bar, and according to inversion law, if we take 2 times inversion of a given variable, it gives the original value, the original variable. So for example, a double bar is equal to a, and this is the activity. And now, so properties of Boolean algebra. So as so far we have seen the laws of Boolean algebra, and now the properties. So the basic laws of Boolean algebra that relate to the commutative law allowing a change in position for addition and multiplication. And what associative law is doing is associative law allowing the removal of brackets for addition and also the multiplication. The distributive law allowing the factoring of an expression are the same as the ordinary algebra. And each of the Boolean laws, as we see already, gives just a single or 2 variables, but the number of variables defined by a single law is not limited to this. And Boolean laws are given above are used for simplifying the complicated digital circuits. And now is the Boolean function. So a Boolean function is described by an algebraic expression called Boolean expression. So it consists of binary variables, the constants 0 and 1, and the logic operation symbols. For example, if the function f of the variables a comma b comma c comma d is equal to a plus b c bar plus a d c. So this function is taken for example. So here this f of a comma b comma c comma d is called a Boolean function, and this is the output. And the right hand side term a plus b plus c c bar plus a d c is the result of the given function f of a comma b comma c comma d. And now a very important law in Boolean algebra is the De Morgan's law. So De Morgan law is given by 2 theorems. So one is for addition and another one is for multiplication. So according to theorem 1, a dot b the whole bar is equal to a bar plus b bar. So this means the product of the 2 variables a comma b and its complement is equal to the complement of the individual addition of the individual variables, that is a dot b whole bar is equal to a bar plus b bar. And next is theorem 2 is a plus b the whole bar is a dot b bar, a bar dot b bar. That means the complement of the addition of a and b is equal to the complements of the product of the individual variables, that is a plus b the whole bar is equal to a bar dot b bar. So these two laws are the Boolean, the De Morgan's law, which are the important laws from the Boolean algebra. Now the assessments, types of Boolean law, as we have seen. 2 properties of Boolean theorems. We have discussed the properties. And now we have seen the De Morgan's law. A plus b the whole bar is equal to a bar dot b bar, and ab the whole bar is equal to a bar plus b bar. Thank you.